Hi everyone, welcome back to Solo Dev. Today I'm going to show you how to make your Unreal Engine projects more flexible and scalable with the Global Messaging System. Whether you're working solo or in a big team, messaging systems keep your code clean by letting game systems talk to each other without direct dependencies. Let's get into how it works, how to implement it, and why you'll love using it. A messaging subsystem is like an in-game post office. System sends messages with a gameplay tag, and anyone interested can subscribe and react. No need for direct connections or casting objects anywhere. So why would you use this? It decouples your systems. It reduces spaghetti code, and it makes your game more modular and testable. Our first step, we're going to want to go into our build.cs file, and we want to add struct utils to our public dependency module names section. Okay, now that we have that in there. So what I've done, I've already pre-coded this one since it's more of a complex example. So we won't code this live, but I've created a subsystems folder, and I've created our global messaging subsystem .h and .cpp. And what I'm going to do is I'm going to take you step by step on this code so that you can understand this. It gives you time to copy it as well if you want to implement this into your own system. And then once you understand it fully, you can make the changes you want to make. This global messaging subsystem uses gameplay tags. I'm a big proponent of gameplay tags in games, and most AAA games that are using Unreal Engine will use gameplay tags. So if you're not, it's probably something you want to read up on and implement. And I'm sure I'll be doing a video in the future on gameplay tags themselves. But our system here uses gameplay tag as the kind of the mechanism used to subscribe. So, for example, I want to subscribe to messages.hit. And so when something is hit, I'll receive a message in a specific class or blueprint that I've subscribed to that message as. Okay, so we've added the gameplay or the game instance subsystem class or .h, the gameplay tag container.h, struct-util slash instance struct.h, and struct-util types.h. These are going to be very important, and we'll explain those here in a second. Next, we have our delegate. It's a 2-param dynamic delegate. And this dynamic delegate type, think of it as a special C++ callback that can be assigned in Blueprint or C++. It lets you hook up functions that will be called whenever a message is broadcast. It takes 2 parameters, the message itself, which is wrapped in a F instance struct, and a message tag, which tells us what kind of message it is. Next, we have our ST listener handler. This struct acts like your ticket for the messaging system. When you register to listen for messages, you get one of these handles back. It keeps track of which message tag you're interested in and gives you a unique listener ID. This makes it super easy to unregister or manage listeners. The message tag property. This property records the tag associated with your listener so you know exactly what kind of message this handler is listening for. And then the listener ID. Every listener needs a unique ID, and that's what this property is for. It helps the system keep everything organized, especially when you have lots of listeners. Global Message Subsystem. This is the heart of the system. This is a game instant subsystem, which means it lives for the entire runtime of your game. Its job is to manage all the messaging between systems, so you can send, receive, and unregister listeners for struct-based messages, either in C++ or Blueprint. Since we do have it marked as a game instant subsystem, the engine will automatically load for you, and it makes it available throughout your whole game. So register game message listener. We're in the C++ section, so this is for C++. This template function is for C++ users. You tell it what struct you want to listen for and provide a callback function. When the message of that type comes through, your callback runs. It even lets you assign an owner, making cleanup easier. The unregistered game message listener. The unregistered game messaging listener. Once you're done listening, you call this function with your handle. That tells the system to remove your listener so you don't get called again. Broadcast. If you want to send a message, use this template function. Just specify the tag and your message struct, and the subsystem will take care of notifying all listeners. Now we're into our blueprint section. And these are the functions that support blueprint implementation of our messaging system. Register listener BP or blueprint. This is a blueprint friendly way to register a listener. You provide the tag, struct type, delegate callback, and an owner. Works great for designers who don't want to touch C++. Unregistered listener BP. Use this in blueprints to remove a listener with its handle. Keeps things neat and prevents memory leaks. Broadcast message BP. Blueprint version of broadcasting a message. Pass it a tag and your struct, and every matching listener gets the call. Get total listener count. Want to know how many listeners are currently registered? This function will tell you which is useful for debugging or stats. Get listener count by tag. If you want to see how many listeners are registered for a particular tag, maybe to see how many systems care about a certain event, this function is for you. Now, our private section. So the fListener info struct, this struct isn't exposed, but it keeps track of each listener, including its ID, what struct it's interested in, whether it's using Blueprint or C++, and even who owns it for cleanup. Listener map. This is a map, think of it as a table, where each tag points to an array of listeners. It's how the system knows who to notify when a message is sent. Next, listener ID. This keeps track of what the next unique ID will be for the listeners. Simple but effective. Register BP struct listener underscore internal. This is an internal engine for adding listeners called by both the C++ and Blueprint registration functions. It does all the real work so you don't have to repeat code. Broadcast underscore internal BP. This internal helper handles broadcasting messages to all relevant listeners when you call the public broadcast function. Okay, let's look at the implementation. So our register game message listener. This function is called when you want to stop listening for a particular message. Maybe your object has been destroyed or you just don't care about the message anymore. This function finds all listeners matching the tag and removes the one with the matching unique ID, keeping the message system clean and efficient. Our register BP struct listener internal. This is the real workhorse for adding listeners, called by both the Blueprint and C++ API. It creates a fListener info record with everything needed, struct type, delegate, and owner. It adds the listener to the right tags list and returns a handle so that you can unregister later. This pattern is great for keeping listener management centralized and robust. Listener BP. Under the hood, it just calls the internal function with a Blueprint delegate, so everything is still managed in one place. This keeps the Blueprint and C++ workflows in sync and bug-free. Unregistered listener BP. Similarly, when you want to unregister a Blueprint listener, call unregistered listener BP with your handle. This removes the listener with a specific ID from the tags array, so you won't get any more callbacks you don't want. Broadcast message BP. This is a public-facing function. Initially, it hands off the work to broadcast message underscore internal BP, so all the logic stays dry and easy to update. and our broadcast message internal BP. This is the heart of the broadcast logic. When a message is broadcast, we look up all the listeners for the tag and go through each one. If the owner still exists and the struct types match, we call their blueprint or C++ callback. If a listener's owner has been garbage collected, we mark it for removal to keep things tidy. After looping, we clean up any dead listeners. This ensures memory is managed and there are no dangling callbacks. So it basically, within the logic, it cleans itself just in case one of your components or classes did not unregister before they were destroyed. They'll be caught here as well. Get total listener count. Adds up every listener across all tags and returns the total. Super handy for debugging or for stats in your game. Get listener count by tag. If you want to know how many listeners are registered for a particular message type, get listener count by tag will fetch that number. Great for profiling, monitoring, or UI feedback. Let's pay special attention to listeners map. All listeners are organized in a map where each tag points to an array of listeners' info. This is a data struct that powers the whole system, making lookups and management blazing fast. With this setup, your game can send and receive structured messages without coupling systems together. If you want to change or expand your architecture later, you won't have to untangle spaghetti code. Everything is just managed and maintainable. So let's see how to implement our new messaging system. We'll start with C++. Let's go over to our player character classes. And so we're going to add our H file for the Global Messaging Subsystem. And down here, I put it in the private. We have a function that I call onGlobalMessage. That is our global messaging payload. And then we have a property, as we're only going to implement one message. So we have a property for global listener handle, and it's just our handle that we get back from registering to listen for a specific message. Let's go into our implementation. So in our begin play event, we grab our global messaging subsystem from the game instance subsystem. We create our request gameplay tag. We're using message.health.changed. And then we register to listen to this message. We pass in the message tag. We give it our struct payload, which we'll see this class here shortly. And when that event is received or that message received, we're telling it to call this function with the payload, which we'll see here shortly. In our in play, we grab our subsystem again, and then we unregister the handle. That's the handle that we got back that we stored from our register game messaging listener. We call that, and that cleans things up to ensure that we're not having any memory leaks. And then I place it here down at the bottom, which is that on global message that we told it to call with our payload. And simply what we're doing in here is we're creating a F string and then passing that to on add screen debug message so that we can see it on our editor screen. We're going to go into our health component. And our health component is where we're wiring up the broadcast. So I placed the global messaging payload structure within our health component. And this is the struct that we want to pass as the payload. So anyone that's listening to that message.health.changed will receive this struct. And the way our message system is set up is it allows us to pass in any struct. And so it's very flexible that we can pass data around. Now, of course, you don't want to pass a massive structure around. You could, but you would generally like to keep these things as small as possible so that the message is lightning fast. So in our example, I just placed the tag I have a property to hold the tag that we're using for the call and the current health value. So we go into the implementation of our health component. And in our function set health, this function is where the health value is set, either from taking damage or just directly set. We want to broadcast or send our broadcast message from within here. So we get our global messaging subsystem again, of course, checks if it's valid. We create our gameplay tag, same gameplay tag that we've seen before. And then we create our payload. So our payload is just simply the global messaging payload struct, and we set our two values, and then we pass that into the broadcast message function. If we go over to the broadcast message itself, or in our template message struct, you will see that it creates the instant struct with our message for us. This keeps us from having to constantly create the instant struct around our struct. The broadcast message will do it for us. It's a nice handy helper there. Okay, to test this in C++, I have a test input action, an event that I have created and wired to our character class. And when I push the T character, it calls this text function. And what I'm doing is I'm just calling the take damage and reducing it by 10. So inside of our editor, we'll hit play. And if I hit the T key, you see our global message. So basically what it did, I hit the T key, which called our test function, which told our health component to take 10 float damage. And within that set health that we showed earlier in the video, it reduces it by 10 and it calls that broadcast message, which then paints it to the editor screen. And we're seeing that our global messaging system is working in C++. All right, now, so let's do it in Blueprint. We go to our third person character, and in our begin play, we want to grab our global messaging subsystem. It's already initialized by the engine. So we want to register listener BP. And we want to fill out these properties. So we have our message. And if you don't know how to create gameplay messages, you go into the editor or edit menu, project settings, gameplay tags, manage gameplay tags, and then you can create your own gameplay tag here, or you can put them into data tables and add the data tables if you like. But we already have ours created, so we're going to select the message we want to monitor for. Our type is going to be our global messaging payload that we created, that struct. We want the owner to be this blueprint, so we're going to get a self-reference, which is important for Blueprint. You need that self-reference or you will not receive the call. And then for our callback, we want to add an event. Doesn't matter what you name it. First thing we want to do is take our message and get instant struct value. This gets that instant struct, which is basically the container for our structure, for our structure that we're passing in our payload, is wrapped in this instant struct. So we get that, and then if it's valid, we want to break our ST global messaging payload. Here we go. We break this out, and the tag, we're going to get the tag name. We're going to need that name. And then let's get a format text, because we're going to print this to the screen. Let's see, a message like, print, new health, and then let's say health, and tag. All right, now give us our parameters. Tag name goes here, health goes into here. And then we want to get a print screen, so we can print this to the screen. 5 seconds. Let's have a lighter color, as the C++ we're showing on the screen as black. So let's print this one as a lighter color. And then connect this to our string. Great. Okay. And that should be all we need for our begin play. And for our end play, we get our global again, and then we want to unregister listen to BP, connect that. And oh, we forgot to store the handle in a local variable. Just call it handle for our sample. So we need this to unregister, so we don't have any memory leaks. And that's pretty much it for the blueprint. So basically, we're calling our global messaging system, telling it to register with using our register listen BP. We're giving it our message tag. We're giving it our struct that we want to send in the payload, which for us is our global messaging payload structure. We provide this blueprint as the listener owner, and which is very important, because you will not receive a callback when it comes to blueprint if you did not provide a owner. And then our callback event will be called once the message is fired. And what we're doing here is we're grabbing our instance struct. So our payload is wrapped in an instance struct. So our message is the instance struct. The payload is in it. So we need to get that instance struct value, and then we break it, and that's how we get our payload. And this is what we're expecting, is the ST global message payload. And what we're doing is the tag and the payload, we are getting those and placing that into a text and using the print screen. We could also get the item tag and then get the tag name and pass that into here too if we wanted to. They're both the same, so compile. Okay. And for our in play, we're getting our global messaging system, and we're calling our unregistered listen BP and passing in the handle that we got back from our register event. And we're going to hit play. So when I hit the T key, as you see, the C++ event, our message fired, as well as our blueprint message has fired. And they're in 2 different colors. So you see that they're working both. You can have both at the same time or use one or the other, depending on your game. If your game is using mostly blueprints, or if you're using mostly C++, the system that we have come up with will work for either one. That's it, guys. Hope you learned something, and I hope this was a great topic. If you want scalable professional game code in Unreal, messaging systems are a game changer. Try adding one to your project, and you will thank yourself later for doing that. If you got any questions or comments, please put them below. I'll try to answer all of them. Please like and subscribe. I'll see you guys next time. Thank you.